Good morning, students. Here is the important points that we have discussed in day 1. So followed by Rutherford's nuclear model. It is also Rutherford's planetary model. Then the experimental setup by Giger and Marsden. So that is alpha particle scattering experiment, the experimental arrangement and conclusions of the experiment with the help of a graph. So in that, the 3 important conclusions, that is more than 99% of the alpha particles scatter without scattering, and only 0.14% of the alpha particles scattered by an angle more than 1 degree, and so that conclusion we have studied, and explanation why alpha particle deviates from its path using Coulomb's law as well as Newton's second law. So then we have studied one more important factor that will help us to find the scattered rays, that is impact parameter. So in impact parameter is the perpendicular distance from the velocity vector to the center of the nucleus. So if the impact parameter is small, then scattering angle is high. Parameter is approximately 0, so the scattering angle is maximum 180 degree. As the impact parameter increases, angle of scattering also decreases. So then one more point you have studied, there is distance of closest approach, where you have applied law of conservation of mechanical energy. So kinetic energy is converted into potential energy. You have equated that, and you got the expression for distance of closest approach, that is R equal to 1 by 4 pi epsilon naught 2 Z square by Ek. In your study material it may be R naught. So that is just the notation, because R we have used as distance from nucleus to position of the electron. So you can use for distance of closest approaches R naught 1 by 4 pi epsilon naught 2 Z square by Ek, where Ek is the kinetic energy given to the alpha particle. So then using Rutherford's alpha particle scattering experiment, you found the expression for energy of the electron in the electron's orbit, that is minus E square by 8 pi epsilon naught R. There the significance of negative sign also we have discussed, that is electron is bound to the nucleus. If at all you want to make the electron free, you have to supply energy equal to minus E square by 8 pi epsilon naught R. So using the same method, you have also find the relation for radius of the electron orbit and velocity of the electron in its orbit. So then you find the limitations of Rutherford's atomic model. So from there we have to start. Meanwhile, I have given a problem to solve in the previous class. So the problem is, I'll read once again. It is found experimentally that 13.6 electron volt energy is required to separate a hydrogen atom into proton and an electron. Compute the orbital radius and the velocity of the electron in a hydrogen atom. So I hope you got the answer. This is a simple question. They have given the total energy of the electron. So what is the total energy? 13.6. You know the expression for total energy. What is that? E square divided by 8 pi epsilon naught R, which is equal to how much? 13.6. So this is in electron volt. We want a radius. Radius we want in terms of meter. So that means this energy expression also in terms of joule. That means you multiply by 1.6 into 10 to the power minus 19. So you have successfully converted from electron volt to joules. Now if you want R, so which is equal to E square. E square is 1.6 into 10 to the power minus 19 whole square divided by, 1 by 4 pi epsilon naught is 9 into 10 power 9. Then what is remaining here? Remaining here is 2. So into this entire term comes here, that is 13.6 into 1.6 into 10 to the power minus 19. So this will give you the radius value. So here 1.6 10 to the power 9 will cancel. So this is 10 to the power minus 9 plus 9. So that is 10 to the power 10. Then 1.6 into 9 by 2 into 13.6. When you do that, so you will get radius of the orbit as 5.3 into 10 to the power minus 11 meter. So that is the radius of the electron. That is the first question they have asked. The second question they have asked there is to find the velocity of the electron in a hydrogen atom. So you know the formula for velocity of the electron, that is E by square root of 4 pi epsilon naught into mr. So when you substitute the value of E, 1.6 into 10 to the power minus 19 divided by square root of 4 into pi value is 3.14. Now what is epsilon naught? Epsilon naught is, you will understand more about epsilon naught in the lower part, that is classical electromagnetism, in topic number 1 as well as in topic number 2. You'll understand more about epsilon naught. The value of epsilon naught is 8.857 into 10 to the power minus 12 into mass of the electron 9.1 into 10 to the power minus 31 kg into radius. You got the radius value just now, that is 5.3 into 10 to the power minus 11. So when you solve this, you will get the answer as 2.2 into 10 to the power 6 meter per second. So now you got a fair idea what is the value of the radius of the electron orbit, and very important, velocity of the electron in the orbit. The velocity of the electron in the orbit is very high. It is of the order of 10 to the power 6 meter per second. That is very important, that 10 to the order of the velocity of electron, for our further discussion. So I hope all of you got the same answer. So if you have not done, then copy this solution. So we are discussing about limitations of Rutherford model. So one major drawback of the Rutherford model is, if this is the nucleus According to Rutherford, electrons are revolving around the nucleus. But if you look at the orbit of the electron, he did not mention anything about orbit of the nucleus. That means if there are infinite orbits around the nucleus, electron can present in any of the orbit. So this is also possible, this is also possible. I can draw infinite orbits around the nucleus. So electron can be present. And in that orbit, electron is basically, it is under uniform circular motion, and you know from your first PU knowledge that any body which is under uniform circular motion is under accelerated motion. I have explained you in the previous class. Its magnitude of the speed may not change, but direction continuously changes. So, much prior to Rutherford, as I mentioned, Maxwell showed that accelerating charge should emit energy in the form of electromagnetic waves or in the form of photons. So here, when electron revolving around the nucleus in any orbit, so it is under accelerated motion. So it should emit energy. So as it emits energy, its energy decreases. So slowly it is tending to move towards the nucleus. So it comes like this, comes like this, comes like this, comes like this, finally collapses into the nucleus. Then what is the question of stability of the nucleus? So in that case, nucleus is not stable. After some time, electron will fall into the nucleus and atom collapses. So this is the major drawback of Rutherford model. Now the question comes, where did Rutherford's model went wrong? Whatever he said regarding the structure of the atom, we are very much okay with that. There is no question regarding that. So, but regarding the stability of the nucleus, there are some issue with the Rutherford model. So we need one more scientist who come up and modified this Rutherford model. So that model we need to study. So before we enter that, I'll tell you a small story. So there was a student in a college. One question is asked for him in our exam. A student wrote the answer to that question, but the professor gave 0 marks for that question. Now student claimed that his answer is correct, so he wants marks. So arbitration is failed. Rutherford is selected as chief of arbitration. So Rutherford met the professor and he saw the question. The question is, you have a barometer, and using that barometer you have to measure the height of a building. So this is a simple question from fluid mechanics. You can easily solve that question using techniques of fluid mechanics. Just by measuring the pressure difference, you can calculate the height of the building. So when you look at the answer of the student, he wrote a very simple way of measuring the height. So just a 6/7 standard method he used. So therefore asked with the student, what kind of answer you have written here? Is it the right way of finding the answer? So student said, there is nothing wrong in my answer. Just because my method is not according to the professor's method, how can you give me 0 marks? So method is not mentioned in the question. They have just asked the question. So now what Rutherford did is he gave extra 10 minutes to the student and asked him to answer the question once again in a different way, not the way he has answered for the first time. So Rutherford was expecting that this time he used the method of fluids to find the answer. So at the end of 10th minute, student didn't reply. So Rutherford went and asked, "Do you have any other answer?" So student replied, "I have another 15 ways of answering this question. I was searching which is best out of that." So now Rutherford got curious. He told the student to explain all the 15 methods. So student went on explaining all the weird techniques he has to measure the height of the building. One answer he gave is, you tie a rope to the barometer and just drop the rope to the street and find the height of the rope. That will give you height of the building. So in such a way he went on answering all the weird techniques. Now Rutherford came close to him and asked, "Honestly, you don't know the right way of answering this question using fluids." The student replied, "I do know the answer using simple fluids technique, but what I don't want is my professor telling me to what to think and what to do." So that student later won 2 Nobel Prize in physics, and that student is Niels Bohr. So now we are studying what is Bohr's postulates, Bohr's visualization on Rutherford's model. So as I mentioned, the drawback of the Rutherford's model, the last point we are discussing in the previous class, that is limitations of Rutherford model. So one of the drawback of the limitation Rutherford model just now we have discussed, that is stability of the atom. So here you will understand in the topic electromagnetic waves that accelerating charge will definitely radiate energy. But here you see, electron is revolving around the nucleus with what speed? Just now I have calculated a formula that is around 10 to the power 6 meter per second. So when the speed is 10 to the power 6 meter per second, you cannot apply classical ideas of physics. You have to jump into a new branch of physics, that is quantum physics. Luckily, the Bohr had a very good view on quantum physics. He can visualize quantum physics better than any of the scientists in physics. So he visualized atom in quantum picture and gave his postulates. So here, since the speed of the electron is 10 to the power 6 meter per second, we need to consider the waves associated with the electron. In the last chapter, that is dual nature of matter and radiation, the matter waves lambda equal to h by p, so which is also h by mass into velocity. So you know, as wavelength becomes larger and larger, the wave nature is not significant there. But here if you see, h is 6.6 approximately into 10 to the power minus 34 divided by mass of the electron is 9.1 into 10 to the power minus 31 kg into speed is 10 to the power 6. So this will come approximately, this is 10 to the power minus 34, and then it goes to, this will be minus 3. This will be, when it goes to numerator, this is minus 3. Again here it is minus 6. So that will be 10 to the power minus 9. So approximately it will be in terms of angstroms. In terms of few angstroms. So wavelength is very small, so that we need to consider the wave nature of the electron. By considering the wave nature of the electron, that is by quantum picture of the electron, now we are slowly moving into the postulates of the Bohr's. So we'll start with postulates, Bohr's postulates. So basically Bohr is also a student of Rutherford. So he studied Rutherford's model for a long time. And what Rutherford said there? Rutherford said that there are infinite orbits where the electron can exist in all the orbits. So first postulate what Bohr gave is electron cannot exist in all the orbits around the nucleus. It can present only in some special orbits, and he called that orbit as stationary orbits. So electron present only in those orbits. That special orbits are named as stationary orbits. Now, what is the speciality of that stationary orbit? The speciality of that stationary orbit is when electron is present in this stationary orbit, it do not radiate any energy. Now the question comes, electron is still revolving around the nucleus in one of the orbit. So Bohr just named that orbit as stationary orbit, but electron is still energy. So to get that answer, you wait for some time. So first postulate of the Bohr is electrons revolve around the nucleus only in certain stationary orbits without emission of radiating energy. So there are many stationary orbits around the nucleus, but not all the orbits are stationary. Only few selected orbits are stationary orbits. So in those orbits, electron can exist. So there is a difference between first orbit and next orbit, and the third orbit and the fourth orbit, such that till the nth orbit. So that is the first postulate of the Bohr. Now we will slowly move to the second postulate of the Bohr. So already we came to know that electrons orbit only in those special orbits called stationary orbits. So each orbit is has its own angular momentum quantum number n. So here electron is revolving around the nucleus. It is exhibiting circular motion. So the angular momentum of the electron when it is in the stationary orbit is integral multiple of h by 2 pi. So angular momentum of the electron in its stationary orbit is integral multiple of h by 2 pi, where n is the principal quantum number. That is, for the first orbit n will be 1, for the second orbit n will be 2, for the third orbit n will be 3. Now if you have confusion like how Bohr got this logic of angular momentum equal to h by 2 pi, again you have to wait for some time. So all the proofs will be given together for that stationary orbit as well as for this. So second postulate of the Bohr clearly says that when electron revolve around the nucleus, the angular momentum of the electron is integral multiple of h by 2 pi. What is n there? N is called principal quantum number. So this is also called Bohr's quantization rule. So Bohr's quantization rule says that basically electrons can be present only in those orbits, which obey this condition, that is L equal to nh by 2 pi. So there will be some gap between first orbit to second orbit, and again there will be some gap from first, second orbit to third orbit. So third orbit to fourth orbit, there is a few gaps. So that is what this quantization rule says. So now, if you move to the third point of the Bohr's postulate, so in third point says that electron in this stationary orbit can jump low energy level provided by absorbing some energy from the external source. So electron, suppose it is in the n equal to 1 state, you supply sufficient amount of energy So then from n equal to 2 state to, it can jump, so let's say example n equal to 3 state. So electron can jump from n equal to, if I take n1 equal to 2, then it can jump to n2 equal to third state by taking energy from the outside. Similarly, electron can jump from higher energy level to lower energy level by emitting the photon. Suppose electron is in the higher energy level and its energy, I'll name it as E naught. So E naught is the energy of the higher energy in higher state, and EI. So basically E naught is the energy in the notations you can follow anyhow. EI is, I'll take energy in the initial state, and E naught is the energy of the final state. Then electron jumps from initial state to final state. Then it emits a energy E, which is equal to E naught minus EI. Now the question comes, this energy, how it is emitted? It is in the form of photon, and energy of the photon you have studied in the previous class, h nu. So h nu equal to E naught minus EI. So from this you can also calculate the frequency of the emitted photon. So what is the frequency of the emitted photon? Frequency of the emitted photon is E naught minus EI by h. So this is the third postulates. So where E naught is the energy of the final state and EI is the energy of the initial state, you can say this is the outer orbit and this is the inner orbit. So these are the three important postulates of Bohr. So if you revise it once again, what is the first point? First point is the electrons revolve around the nucleus only in certain special orbits called stationary orbits. And what is the angular momentum? Where n is the principal quantum number. And what about third point? Electron can jump from outer orbit to inner orbit by emitting energies of suitable frequency, that is h nu equal to E naught minus EI, and from that you can calculate the frequency of incident radiation, that is nu, so frequency of that radiation emitted, that is E naught minus EI by h. So this is very famous Bohr's postulates. So if the question is asked what is the stationary orbit, what is your answer? Answer is a stationary orbit is the one in which moving electron does not radiate energy. Electron, he treated electron as a wave, not as a particle. You have to remember what Maxwell said, that is for a charged particle. So there the velocity of the particle is very small, so that its wavelength associated with the electron is very high. So wave nature is not dominant there. But here in the case of electron revolving around the nucleus, its speed is very high. So you have wave nature of the electron is dominant, not the particle nature. On that basis he introduced the stationary orbit as well as second postulate as well as third postulate. So remember this, very, very important. Further, based on Bohr's postulate, now we are going to derive the relation for extension electron in the nth orbit of a simplest hydrogen atom. So this is the nucleus of the hydrogen atom, and this is the revolving electron, and speed of the electron, and plus ZE. In fact, first I will consider a general atom, then we can at the end we can put Z equal to 1 for hydrogen atom, and distance from nucleus to the electron I'll take it as R. So this is the situation given here. So charge of the electron is E. Basically we need to find out the radius of the electron. So here what electron is doing? Electron is exhibiting circular motion. I have told you in the previous class, any body is and centripetal force is no longer a fundamental force. It is means some other force must behave like centripetal force. Here, which force behaves like centripetal force? It is the Coulomb's force of attraction between electron and nucleus. What is the formula for Coulomb's force? I'll write once again, which I have written in the previous class. This is charge Q1, this is charge Q2, separated by a distance of R. Then force between them F equal to 1 by 4 pi epsilon naught Q1 Q2 by means both the charges are positive, then force is repulsive. That itself accounts for the sign. If the charges are one is positive and one is negative, then the force is attractive. That itself accounts for the sign. So no need to mention the sign of the charge here. So here if you see one charge is negative, that is electron, another charge is positive, nucleus. So there will be electrostatic force of attraction between them. That is why electron is still bound to the nucleus. That is why it is a bound system. So what do you expect the total energy? What must be centripetal force Fc, so which is equal to Fe, that is electrostatic force of attraction between electron and nucleus. What is Fc? mv square by R, general expression for centripetal force. What is electrostatic force of attraction between nucleus and electron? 1 by 4 pi epsilon naught into what is the charge of the electron E into what is the charge of the nucleus Ze divided by what is the distance between them R square. So here 1 R will cancel and take this R to this side, then it becomes mv square R equal to Ze square divided by 4 pi epsilon naught. Let it be equation number 1. So I told you we are deriving here the radius of the electron in the nth orbit based on the Bohr's model. So we will use the second condition, that means of the Bohr's model, that is angular momentum of the electron in the nth orbit. Can you guess what is the answer? L equal to nh by 2 pi. Now, what is the expression for L? So expression, if a body is moving in a circular path and its mass is m, speed is v, its distance from the fixed point is r. What is the expression for angular momentum that you have studied in the rotational mechanics? R into P into sin theta, R cross P. So here the angle between R and V is 90 degree. The momentum of the particle, mass into velocity. Using this, what is the expression for L? Mass into V into R. This you have studied in rotational mechanics, the angular momentum of the revolving body. So what is the angular momentum of the revolving body? M into V into R. So we will incorporate that result here. So what is L? L is M into V into R equal to NH by 2 pi. So now we have used the concept of centripetal force. We have used the concept of that second postulate of Bohr's hypothesis. Then now we have to do little mathematics to get the final answer. So physics part is over. So we'll find out the radius. There is simple mathematics. First you square this equation, that is m square v square r square equal to n square h square by 4 pi square. This will be equation 2. So what you do is you do equation 2 divided by 1. Now here what you have here, m square v square r square. What you have here, m v square r. So that means v square cancel, 1 m will cancel and 1 r will cancel, remaining is mr. So which is equal to, this will be n square h square by 4 pi square whole divided by, this will come z e square by 4 pi epsilon naught. That means 4 pi epsilon naught will go to the numerator and z e square goes to the denominator. Now you tell me what are the terms that will cancel. 4 they will cancel, 1 pi will cancel. Then I'll move to here this derivation. So what happens to the radius? Radius equal to, so in the numerator what is there, and m into z e square. So this is the radius of the electron in the nth orbit. So since it is the of the r suffix n, what is r suffix n? Epsilon naught n square h square by pi m z e square. So this is the radius of the electron in the nth orbit. Now look at my heading. What I have written? Radius of the electron in the nth orbit of hydrogen atom. So now for hydrogen atom, what is the value of z, students? Z equal to 1. So then this expression reduces to Rn equal to epsilon naught n square h square by pi m e square. That is the expression for radius of the electron in the nth orbit of the hydrogen atom. So this is a simple derivation, very important 5-mark question. So radius of the electron in the nth orbit of hydrogen atom. So whatever I have discussed so far, that is Bohr's postulates and expression for radius of the electron in the nth orbit, it is in page number 96. So go through that, students, and also go through all the points in this. So if you look at the expression of n square h square by pi m e square. Look at the terms in that expression. Epsilon naught is the permittivity of the free space. So that means it is a permittivity of the vacuum. So that value is fixed, as I mentioned, 8.857 into 10 to the power minus 12. That many Coulomb square, Newton to the power minus 1, meter to the power minus 2. That is the unit of epsilon naught. And h is the Planck's constant, 6.63 into 10 to the power minus 34. That is joule second. And pi is a constant, that is 3.14. Mass of the electron is 9.1 into 10 to the power minus 31 kg. And the charge of the electron is 1.6 10 to the power minus 19 coulomb. So that means you can find the radius of the electron in the nth orbit. Substitute this and this. You will get radius of the orbit as 0.53 angstrom into n square. So radius of the electron in the nth orbit is 0.53 angstrom into n square. So that means radius of the electron is directly proportional to square of the principal quantum number. It's very, very important point. Rn is directly proportional to n square. So if you take the ratio of R1, R2, R3, so on, what is the ratio? 1:4:9 continuous. That is the ratio. And now it is very easy to find out the radius of the electron orbits. Now if you look at this point, I have a simple question to you. Whether electron orbits are equally spaced. That means gap between first orbit and second orbit and third orbit, third orbit and fourth orbit, like that. Is it same? Definitely not. The ratio is 1:4. That means from this actually you can easily write radius of the first orbit is 0.53 angstrom. What is the radius of the nth orbit? 0.53 angstrom into n square. So when you take the ratio Rn by R1, what is your answer? Quickly, 0.53 angstrom. Is it? No. 0.53 angstrom will cancel. Remaining is n square. So that implies, what is the radius of the nth orbit? Radius of the nth orbit is radius of the first orbit into n square. So Rn is n square into R1. So that is radius of the electron in the nth orbit. Now you can also find the velocity of the electron in the nth orbit. So how to find the velocity of the electron in the nth orbit? What is the expression for centripetal force? By epsilon naught z e square by r, hydrogen atom. So in fact it is r square. So 1 r will cancel What is velocity? Velocity is E by root of 4 pi epsilon naught into m. E by 4 pi epsilon naught into m. Now, this is the expression for velocity of the electron in the nth orbit of the hydrogen atom. Similar expression we got in the case of Rutherford model also. So now you know the velocity and you know the radius also. Now this is the path of the electron and this is the nucleus. Imagine an electron starts from this point, it goes once round the circle and again comes back to that point. So that time, what do you call the total time taken by the electron? It is time period of the electron revolving around the nucleus, T. So here, whether the speed of the electron is changing? No, it remains constant. Is the formula speed equal to distance traveled by velocity? Is it correct? Speed equal to distance traveled by time taken. So what is the time taken? Time taken is distance traveled by speed v. So what is the distance traveled? When it completes one circle, it is 2 pi r, where r is the radius of the orbit. If you are calculating time period of the nth orbit, then it is the speed of the radius of the nth orbit divided by velocity in the nth orbit. So this is revolution of electron. So frequency of revolution of electron equal to F, which is equal to 1 by Fn is 1 by Tn. What is 1 by Tn? That is Vn divided by 2 pi Rn. So this is the expression for frequency of the electron in the nth orbit. That means how many rotations from you otherwise I've started from expression for radius, then I find the radius of nth orbit of electron using the known constant values. Then I got the relation radius depends on principal quantum number. I got the ratio of radius of the orbits. Then I got the radius of nth orbit in terms of radius of the first orbit. And then expression for velocity, expression for time period, and expression for frequency. So all these points which I have discussed now is given in terms of note points. Note point 1, 2, 3, 4, 5, 6, 7. In fact, note point 5th one I have not discussed, that is here I written for hydrogen like atom. Now the question comes, what do you mean by hydrogen like? Hydrogen like atom means it must have only single electron in its orbit. You take helium, it has got 2 electrons. Then what you have to do? Ionize the helium. Remove 1 electron from the helium. That is helium plus. Singly ionized helium. You take lithium, 3 electrons. How many electrons you have to remove? 2 electrons. That means doubly ionized lithium. You take beryllium, 4 electrons. How many electrons you have to remove? 3 electrons you have to remove. So triply they are all hydrogen like atoms. Their Z is not same for this. For helium Z equal to 2, lithium Z equal to 3, beryllium Z equal to 4. But they have only single electron when you ionize in their orbit. For this, if you want to find out the radius of the electron in the nth orbit, what change you have to bring? What change you have to bring here? You have to just introduce Z here. Remaining all the terms are same. In this expression, you have to just introduce Z. So this value we have known already here. What is that? N square into R1 divided by Z. So that is the radius of the electron orbit for hydrogen like atom. So please go through note points 1, 2, 3, 4, 5, 6, 7. In this, note point 1, 2, 3 is given. After some time I will give the next page. Just go through that. So one more important derivation we are studying here is expression for nth orbit of hydrogen atom. So nucleus of any atom, the approach is similar. In the previous class also I have taken general atom, then at the end I put Z equal to 1 for hydrogen atom. So similar way here, this is the nucleus of the atom having charge plus Ze, electron is revolving around the nucleus with the speed v, and r is the distance from nucleus to the electron. So here we need to find out the energy of the electron. So total energy is obviously sum of kinetic energy and potential energy. So first I will calculate the potential energy of the electron in the nth orbit. So in the previous class we have discussed, this is having a charge q1, one more charge q2, separated by a system, separated by a distance r. Now this is a simple two particle system. Now here, if you want to find the potential energy of the system, then U equal to magnitude of one charge into what? Potential due to the other charge. Potential due to Q2. Now, what is potential due to Q2? That is 1 by 4 pi epsilon naught Q2 by R. What is the answer? 1 by 4 pi epsilon naught Q1 Q2 by R. That is U. So now, I told you, if here any what is the meaning of that potential energy negative? It is a bound system. So in force, I told you attractive or repulsive, that itself accounts for the sign of the charges. But here, if the charge is negative, you have to put that in the expression so that you can say whether it is a bound system or it is a free system. Both are positive, it is a free system. Both are negative, it is a free system. One is positive, one is negative, it is a bound system. If you look at this case, electron is having negative charge, nucleus is having positive charge. So obviously this is a bound system. So potential energy is potential due to what? Due to nucleus into charge of electron. So what is potential due to nucleus? So what type of charge it is? Positive charge. So what is the potential due to positive charge? It is positive. 1 by 4 pi epsilon naught into ZE by R into what is the charge of electron? Minus E. Remember, in the case of force, I have substituted plus E only, because there you have to concentrate only on the magnitude of charge of electron. But here we are discussing about a scalar quantity. So if the charge is negative, you have to substitute minus E. So what is the potential energy? Minus 1 by 4 pi epsilon naught ZE square by R. Let it be equation number 1. The second part is to calculate the kinetic energy. To calculate the kinetic energy, we need the help of, again, the centripetal force concept. You know, who is providing the necessary centripetal force? Many times you have discussed. It is the electrostatic force of attraction between electron and nucleus. mv square by R is a general expression for centripetal force, equal to 1 by 4 pi epsilon naught. What is the force? ZE square by R square. Remember, I have not put negative sign here. So what is mv square from this? mv square is 1 by 4 pi epsilon naught ZE square by R. So I need what? I need half mv square. So what you have to do? Multiply this equation by half. So take it as equation number 2. So you got the expression for kinetic energy, you got the expression for potential energy. What is total energy? Total energy is very simple. Total energy equal to potential energy. Notation is EP, and this, if I take EK, that is kinetic energy, then total energy is EP plus EK. What is the answer we will get? Which is equal to, I can take 1 by 4 pi epsilon naught ZE square by R common. Then what remains in the bracket? Here it is minus 1, here it is plus half. So when you simplify this, what you will get? When you simplify this, energy equal to minus ZE square divided by this minus 1 plus half is minus half. When you multiply here, 8 pi epsilon naught R. Now here, this is the energy of the electron at the nth orbit. That means I'll represent this as En. This also En. What happens to radius? Radius becomes Rn. Now, do you know the value of Rn? Yes, the value of Rn is known to you. What is Rn? Rn equal to epsilon naught n square h square by pi m. I'm not waiting for hydrogen atom, so I have to include z. Z is square. So now what is En in that case? Minus ZE square as it is, 8 pi epsilon naught as it is, 1 by Rn. What is 1 by Rn? Pi m ZE square on the numerator, epsilon naught n square h square in the denominator. Which are the terms cancel? Pi, pi cancel. So remaining is total energy En equal to minus m into z becomes z square, e square into e square becomes e to the power 4 divided by 8 epsilon naught into epsilon naught becomes epsilon naught square, n square as it is, h square as it is. So this is the expression for energy of the electron in the nth orbit of a atom, not hydrogen atom, nth orbit of a hydrogen like atom. So again, if you look at the heading, I have written what? Energy of the electron in the nth orbit of what? Nth orbit of hydrogen atom. So what is the expression for energy? Energy is minus square h square. That is the expression. This is also very important possible 5-mark question. So in your study material, page number 97, they have given energy of the electron in the hydrogen atom, in the nth orbit of the hydrogen atom. Go through that. So this is the expression for energy. So if you look at the expression of energy, even in this case also, see, m is constant, E is constant, 8 epsilon naught is constant, H is constant. So what you can write is energy of the electron in the nth orbit is inversely proportional to square of the principal quantum number. So what does it indicate? As n increases, that is G increases. Why? It is not En proportional to 1 by n square, En proportional to minus 1 by n square. So that means energy becomes less negative, that means it increases. En increases as n increases. So basically this tells you that electrons in the outer orbit has more energy than electrons in the inner orbit. So that is the significance of this. En increases as n increases. Next, here you know the value of m, E, epsilon naught, H. So if you substitute En equal to mass of the electron 9.1 into 10 to the power minus 31 kg, charge of the electron 1.6 10 to the power minus 19 to the power 4 divided by 8 into epsilon is 8.857 10 to the power minus 12 whole square, and 6.63 into 10 to the power minus 34 whole square into 1 by n square. So when you do this, you will get the value of energy minus 13.6. Actually this value you will get in terms of joule. You have to divide this entire expression by 1.6 into 10 to the power minus 19. That time you will get energy in terms of electron volt by n square. Again, remember this answer you will get in terms of joule. This answer you have to divide by 1.6 into 10 to the power minus 19. That time this becomes 3 times. So that will be minus 13.6 electron volt by n square. So what is the energy of the electron in the innermost orbit? Innermost orbit is n equal to 1. So what is E1? Minus 13.6 electron volt. So this is the energy of the electron in the innermost orbit. Now what is the energy of the electron in the nth orbit? That is minus 13.6 electron volt by n square. You just look at these two expressions. E1 is minus 13.6 electron volt. En is minus 13.6 electron volt by n square. So what is En by E1? En by E1 is 1 by n square. So that implies what is En? En is E1 by n square. So just like radius of the electron in the nth orbit is n square times radius of the electron in the first orbit, energy of the electron in the nth orbit is minus 13.6. Energy of the electron in the orbit is energy of the electron in the first orbit by n square. Remember that. Further, so this gives a very important idea of energy levels of the electron. Now, what are the various possible energies of an electron in its orbit? So what is the first energy possible by the electron? That is E1. What is that? Minus 13.6 electron volt. My formula is En equal to minus 13.6 electron volt by n square. What is E2? Energy in the second orbit. That is minus 3.4 electron volt. You have to substitute 4 here. Then you have to substitute 9 there. What is the answer? Minus 1.51 electron volt. Substitute 16 there. What is the answer? Minus 0.85 electron volt. And you substitute 25. What is your answer? Minus 0.54 electron volt. Substitute 36. What is your answer? Minus 0.38 electron volt. Substitute 49. What is your answer? Minus 0.28 electron volt. So on. If you do, when you reach the infinite level, what is your answer? 0. Now you see the energies of electrons. First energy possible at minus 13.6 electron volt. Next energy level possible at minus 3.4 electron volt. Next energy level possible at 1.51 electron volt. These are the energy levels. So that means, what do you think? Energy levels of electron, are they discrete or continuous? Now to get the discrete, imagine this is a multi-story building and you are standing here. Okay. Now you will jump from here. Not to end your life, just to experiment the physics. Okay. So you will jump from here. So when you jump from here, you will directly fall like this. Because gravitational energy levels are continuous. Suppose gravitational energy levels are discrete. One energy level comes here, then one energy level comes here, one energy level comes here, one energy level comes here. Then you will stop here for this in energy level. Then you will jump to this energy level. Then you jump to this energy level. Then you jump to this energy level. Then you jump to this energy level. But practically whether that happens? No. Continuously you will fall. That means this energy is split into those energy levels are continuous. But if you look at the electron energy levels, look at the first value 13.6, next value 3.4, next value 1.51, next value 0.85, next value 0.54. That means there is a gap between first and second, second and third, third and fourth, fourth and fifth. So that is the meaning of energy levels are discrete. What about here? Energy levels are continuous. Here the energy levels are discrete energy levels. This also boosts Bohr's quantization rule. So this is some idea regarding the energy levels of the hydrogen atom, and when the energy level is, when the electron is at infinite distance, there is no interaction between electron and nucleus, so its energy becomes 0. So further, I have told you all this for hydrogen atom. If it is a hydrogen-like atom, what you have to do? It's very simple. If you look at the expression for energy, for hydrogen atom it is minus 13.6 electron volt by n square. So if you look at the expression for energy of the electron, look at here. So in the hydrogen like atom, where Z comes in the numerator. This remaining all these values, no? These we have taken into account, and that came as 13.6 electron volt by n square. So you have to just multiply by Z square. So this is the so now in the previous point here, actually I told you what is E infinity equal to 0. What is the significance of this? So E infinity equal to 0 means your electron is not interacting with the nucleus. That means it is no longer bounded to the nucleus. That means it is a free electron. So if you take the outermost electron, so whose energy is very, very, very less or very close to 0, we treat that electron as a free electron. So we will study in the topic current electricity that there are infinite number of free electrons in a metal, especially in conductors. So those free electrons are the electrons which are in the outermost orbit and their energy is close to 0. So that is the meaning of E equal to 0. So free electron. Now, two more points if I discuss. One is look at the expression for kinetic energy and expression for potential energy. So, expression for potential energy, what is that? Minus 1 by 4 pi epsilon naught Z E square by R. Expression for kinetic energy, what is that? Half into 1 by 4 pi epsilon naught Z E square by R. So what you can write from these two? Potential energy is 2 times kinetic energy. Is it only 2 times kinetic energy? No, minus 2 times kinetic energy. So potential energy is minus 2 times kinetic energy. And look at total energy. What is total energy? Total energy is mz square e to the power 4 by 8 epsilon naught square n square h square. So that means total energy is negative of, in fact, kinetic energy is negative of total energy. So remember these two relations, very helpful in solving the problems in NEET and all. So these two relations, potential energy is minus 2 times kinetic energy and kinetic energy is negative of total energy. Last point here I need to introduce is 8th note point. I told in the beginning itself, electron nucleus system is a bound system. If it is a bound system, what must be the total energy? Not the expression, in terms of sign, what must be the total energy? It must be negative. Look at the expression of energy, expression of total energy, negative. So that again proves that if at all you want to give few electrons to your beloved ones as a gift, you have to supply some amount of energy. So the negative energy indicates that electrons are bound to the nucleus. You have to supply some amount of energy to remove the electron from its orbit. Suppose you want to remove from the innermost orbit, how much energy you have to supply? 13.6 electron volt. From the next orbit, how much you have to supply? 3.4 electron volt. From the next orbit, how much you have to supply? Minus 1.51 electron volt. Like that, if electron is already free, whether you have to supply energy? No, it is already free, its energy is 0. So, but electrons present in the orbit, if at all you want to release them, then you need to supply energy equal to total energy of the electron in that orbit. That is the meaning of that negative energy. So whatever I have discussed here, that is from this point, especially from that energy point, from this point, everything is given in note. In page number 97, 98, note 1, note point 2, note point 3, 4, 5, 6, 7 and 8. Go through that note points from note point 1 to 8. these points. I want to check to what level you have understood. So I have a simple question here that you have to answer in the next class. Here in Bohr's atomic model, Fc equal to Fe that we have taken, in that the electrostatic force between nucleus and revolving electron is inversely proportional to square of the distance. That is known fact from the inverse square law, from the basic Coulomb's law of electrostatic electric charges and fields. Electrostatic force between electron and nucleus is inversely proportional to square of the distance. Based on this only we have derived all those relations for radius, velocity, energy, all those things. Now I will construct a electrostatic force is inversely proportional to R. Practically it cannot exist, already it is, we know it is directly proportional to 1 by R square. But I will construct a system in that electrostatic force is inversely proportional to R, not inversely proportional to R square. My question is, what will happen to velocity and what will happen to time period of the electron? In this hypothetical system, what is velocity of the electron and what is time period of electron? Electron is still revolving around the nucleus, but the force between electron and nucleus is not inversely proportional to square of the distance, it is just inversely proportional to R. So in that case, what happens to velocity, what happens to time period, that you have to tell me in the next class. So in today's class we have discussed the demerits of Bohr's model, then you have discussed demerits of Rutherford's model, then how Bohr's overcome the demerits of Rutherford model. We have discussed radius of the electron orbit, energy of the electron orbit, and we have discussed time period, frequency of the electron orbit and electron-like hydrogen-like atom. In those electron orbits also we have discussed. Go through all the derivations and go through all the important points and try to answer this question in tomorrow's class.